All right, we're about to go on an invisible journey, one that happens millions of times a second, all around us, every single day. First, we're going to build up our understanding of how the web actually works, from the ground up. And then, once we get the rules of the road, we're going to see just how shockingly easy it can be to break them.
I mean, it really does feel like magic, doesn't it? You type a web address, you hit enter, and poof, a whole universe of information just appears on your screen. But behind that split-second load time, there's this incredible, lightning-fast conversation happening all across the globe. Today, we're going to pull back that curtain.
So let's start at square one, with the most fundamental relationship that makes the entire internet possible.
It really is that simple. Think of your web browser, on your phone or your laptop. That's the client. It's the one doing the asking. And the computer that's hosting the website you want to see, that's the server. It's a specialized machine designed to do one thing: listen for those requests and serve up the right information. This back-and-forth dialogue is the absolute foundation of everything. Believe it or not, every single time you visit a site, this exact six-step dance happens. You type the address, your computer has to find the server, it sends out a request, the server sends a response back, your browser builds the page from that response, and then the connection closes. We're going to zoom in on a few of these steps, starting with the one that's kind of critical, step 2.
So how in the world does your browser find that one correct server out of literally billions of devices connected to the internet? Well, it needs the internet's phone book.
And that is exactly what the Domain Name System, or DNS, is. See, we humans, we remember names, like example.com. But computers, they only understand numbers, specifically IP addresses, which are the unique numerical street addresses for every single device online. DNS is the massive global system that translates the name you type into the number the computer needs. And the fact that this system is spread out all over the world is what makes the internet so incredibly resilient.
Now, this process, it's not just one question. It's this incredible chain of command, and it all happens in milliseconds. Your computer asks your internet provider's server, which might ask a root server, which then points it to a top-level domain server for .com, which finally points to the one authoritative server that holds the actual record. It's like a super fast game of telephone to find one single piece of information, the right IP address.
Okay, so we found the server, our browser has sent its request, but how does the server find our specific data, like, when we try to log into an account? To do that, it needs to talk to its database.
And the language servers use to talk to their databases is called SQL, which stands for Structured Query Language. What's so cool about it, as this quote points out, is that it's designed to be readable, almost like plain English. It uses simple keywords like select, from, and where to ask for very specific information. You can almost think of it as hearing the server's internal monologue.
And this is basically what the server is looking at, a simple table. It looks a lot like a spreadsheet, right? It's got columns for ID, username, and password. So when you try to log in, the server's entire job is to find the one single row in this table that perfectly matches your credentials.
And the logic is super strict, very simple. The query it sends says, find me a row where the username is an exact match and the password is an exact match. Both conditions have to be 100% true. That's the rule. And now, we're going to break it.
So we've seen how this system is built. We get the client, the server, DNS, and SQL. Now let's see how an attacker can hijack that SQL conversation to completely bypass security. This is a classic trick called SQL Injection.
Okay, look closely at this. On the left, a totally normal login for the admin user. On the right, the attacker's attempt. They've also typed admin as the username, but then they added a single quote and 2 little dashes. The password? Could be anything. Total gibberish. So how in the world could this possibly work?
Well, here's the secret. Those extra characters, they aren't just text. To an SQL database, they're commands. That single quote is used to say, hey, we're at the end of this text field. And the 2 dashes, that's a universal symbol in SQL that means start a comment. It basically tells the database to completely ignore everything that comes after it on that line. And right here, you can see the absolutely devastating result. The normal query on the left has to check for the username and the password. But look at the hacked query. The attacker's clever input changes the whole command. The database now sees where username equals admin, and then that dash dash tells it to just ignore the rest of the line, completely removing the password check from the equation. It's just gone. So the database just follows its new instructions.
It finds the user named admin, it completely ignores the password check, and it returns the account details. From the server's point of view, the login was totally valid. And just like that, the attacker is in, with full admin access without ever knowing the real password.
So what does a vulnerability like this really tell us about the systems we use every single day? It really reveals just how much trust is baked into the very foundation of the web. Let's just recap what happened here. An attacker used a single quote to break out of the box they were supposed to be in. Then they used a comment symbol to surgically remove the security check. They didn't break the server's language. They used its own rules, its own grammar to make it lie.
And that's the real takeaway here. The web is built on all these layers of protocols and languages, and they all have to trust that the data being passed around is what it claims to be. A hack like SQL Injection shows just how easily that trust can be broken. It makes you wonder, what other little cracks are hiding in plain sight, just waiting for the right combination of characters to unlock them?